Hi kiddos, today we are going to begin discussing functions. So let's get to it. Alright, so a function assigns each member of the domain to exactly one member of the range, okay? You guys should hopefully recall that domain is your x values and range are your y values. So the domain of a function is the set of all x coordinates, okay, the independent variable. So if we were looking at this example, I'll circle all your x values, 1, 2, 6, and 1. Okay, those would be all considered your domain. The range of a function is a set of all the y coordinates. So I'll underline those for -3, -5, and 6. Okay. The zeros or roots, and you do need to know both of these words, zeros or roots, of a function are basically the x-intercepts. So where does that graph cross the x-axis is where you find your x-intercepts, which are zeros or roots. A relation is a set of any ordered pairs. So this example right here is a relation because it's a set of ordered pairs. Now, if we were looking at this to determine whether this is a function or not, you really have to focus in on the x value. You cannot let x repeat. Notice the member of the domain to exactly one member of the range. So if we have more than one number that is the same in the x value, then it is not a function. So as you can see, we have 2 ones, which means this would be not a function. All right, so function notation, basically f of x. One thing that you do need to recognize is that f of x is essentially the same thing as y. So we can actually use these two things interchangeably, okay? So for the following relations, identify the domain and range, and then decide whether or not the set is a function. So remember, domain is our x values, so I will circle them. All right, so -3, -5, -4, -3, -8. You are supposed to, when you list domains and ranges, you should list them in order from least to greatest normally, but I'm not going to be super picky about it. Also, if you have multiples of the same number, you technically do not have to write it more than once, okay? But it's not a big deal if you do. So this domain would be listed as such: -3, -5, -4, -3, -8. Okay, that is our domain. And yes, my little brackets are hideous, I know. And then for our range, I will underline those values: 1, 2, 6, 0, and 1. So our range okay, I guess I can't move that box. We get 1, 2, 6, 0, 1 as our range. Now, to determine whether it is a function or not, we need to look at the domain. So the range doesn't matter. We just focus on the domain. And because I see that I have -3 twice, therefore this is not a function. Number 2, I'm going to circle all my x values to identify my domain. Just makes it easier if I do this. So everything circled is my domain. Everything not circled is essentially my range. So domain is -1, -2, -3, -4, -5, -6. My range, 1, 2, 3, 4, 5, 6. Now remember, to determine whether it is a function or not, we only focus on the domain, and none of those values repeat. So yes, this is a function. Number 3. Here's our relation, and I'm going to circle my domain. And remember, everything not circled is my range. So the domain is 2, 3, -5, -1. And now I want you guys to determine what the range is and whether this is a function or not on your own. All right, analyzing the graph of a function. In order for a graph to be classified as a function, we can use something called the vertical line test. Vertical line test essentially when you have a graph. So for example, let's say I have a graph like this, and I have a graph like this, okay? What you do is you would draw literally vertical lines down your graph, okay? Now, it should only touch your graph at one point. So notice it only touches one time each time that I drew it. That means that it is a function, okay? Now, if I draw my vertical lines here, I notice that it touches more than once each time. So each time I do that line, it touches more than once, so therefore this is not a function, okay? So that's how you use the vertical line test, all right? Remember, domain is all your x values, the independent range is all your y values, and zeros or roots are x-intercepts. All right, so figuring out the domain here, normally what I like to do, especially with figures like this, I actually like to draw, let me use some color so you can see it a little bit better. I actually like to draw a box to box in my graph. Okay, that gives me my limitations. So now I like to put numbers on the outside that correspond to it. So starting from 0, 0, I would go 1, 2, 3, 4. So this is +4 here. Let's go in the opposite direction. From 0, 0, -1, that's a -2. All right, now let's go left, right from 0, 0. So here I would go 1, 2, 3, 4, 5, 6, 7. And the last one to the left, that's -1, -2, -3, -4, -5, -6. Okay, once I do that, it makes the rest of this work a lot easier. Okay, now there is something that you need to be probably reminded of, and hopefully you notice in the picture you see a closed circle, okay, which is basically a circle that's filled in with color, or you see an open circle. Now, there's a difference between the two, obviously, okay? When we see open circles, so not filled in, okay, we're using less than or greater than symbols. If it is a closed circle, then we're using the less than or equal to or greater than or equal to symbol, okay? The reason why we use those symbols is because this is saying that the answer is included. So that's why we have the or equal to option. Okay, so anytime it's a closed circle filled in, you're going to have a symbol that's either less than or equal to, greater than or equal to, because the value there is actually included. When you have a whole, an open circle, okay, the answer or that number is not being included. So that's why we get rid of the not equal to symbol. All right, so remember domain is your x value, so it goes left to right. All right, so our values are -6 and 7. X goes in the middle. -6, closed circle, so you're using one of these two values, okay? And hopefully you see that x is bigger than negative 6, so we're going to use less than or equal to. And then 7, x is going to be less than 7, so you use the greater than. So the answer is, I meant less than. So x, okay, our domain is negative 6 is less than or equal to x, which is less than 7. Okay? Our range, notice, remember range is your y value, and your y value goes from the bottom to the top. Okay, so keep that in mind. So we're going to begin at the bottom. So my bottom number here is the negative 2, and we're going all the way up to 4. Now at negative 2, we have the open circle, so we're going to be using one of these two symbols. At 4, you have a closed circle, so you'd be using this symbol, okay? So that's kind of how you can reference it. So our range is negative 3. No, that's negative 2. So that's a little typo there, unless I can't count right. No, that's negative 2. Negative 2 is less than y, which is less than or equal to 4. Now, if you always go in the directions of left to right and bottom to top, then you're pretty much always going to use the less than symbols, okay? When you start going right to left or top to bottom, that's when you would be flipping your order. So I always like to go left to right, bottom to top, because I think it makes it easier, because I always use less than or equal to or less than, okay? Zeros, meaning the x-intercept. So this graph crosses the x-axis at that point right there, which is about 1, 2, and a half. So our 0, the x-intercept, is 2.5, comma 0. So notice we write our x-intercepts as ordered pairs. And yes, this is a function, because if I were to do the vertical line test, every single time I draw a vertical line, it only touches the graph one time. So yes, it is a function. All right, so next problem, number 2. We're going to state the domain range, find the zeros, and say if it's a function or not. Now notice for this graph, I always like I said, to draw boxes. Well, we've got little arrows at the ends. So technically, what does that mean? Technically means that this continues forever in that direction and forever in that direction. So the only boundary I have is right here. So notice that's why I drew a line right there, okay? So that's as high as I'm going. All right, so let's fill in our numbers here. So we'll go starting from 0, 0 as always. So let's see where we get to. We get 1, 2, 3, 4, 5, 6. So the highest we're going to go is 6. All right, counting going down, well, because we got arrows, that means I can continue forever in the negative direction. So we're just going to write negative infinity, because I am not going to count. And now let's look left and right. So if we go from 0, 0 to the right, again, it's going forever in that direction. So that would be positive infinity. And it does the same thing going towards the left, so that would be negative infinity. All right, so the only limitation we have is up here at the top with the 6. Okay, that's the highest we're going to go. So our domain, okay, remember domain is your x value, which means we're going left to right, so left to right. And notice we're going from negative infinity to positive infinity. So that means we go forever in both directions, which basically means that x is all real numbers. X can be any possible number. All right, now our range, we do have a limitation to, okay? Notice we cannot go above 6. So our y values, because that's our range, are going to be numbers less than 6. So our range is y is less than or equal to 6. All right, and our 0, the x-intercept, so notice in this graph we have 2 of them marked for you, there and there. And that is at positive 1, 2, 3, 4, 0, and then negative 4, 0. All right, so the question is this a function? Well, if we draw our vertical lines, notice it only touches our graph once each time, so therefore, yes, it is a function. All right, so problem number 3, first thing that we're going to do is we're going to draw a box around our figure here so that we can see our limitations. So that's essentially what your box should look like. Now that we have that done, now I can actually put our number values on the outsides so we know what our restrictions are. So let's look at the x-axis first, since it's independent. So from 0, 0, that's where you always start. Let's go to the right. We're going to the right 1, 2, 3, 4, 5, 6 units. So I'm going to put a 6 there. Then we go to the left from 0, 0. We're going 1, 2, 3, 4, 5 units. So I'll put a 5 there, but that's a negative 5. Don't you forget that. All right, so now let's look at our y value. So again, still from 0, 0. Let's count up 1, 2, 3, 4, 5, 6 units going up. And if we were to go down, we got 1, 2, 3, 4 units going down, which makes it a negative 4. Okay, that totally helps in writing domain and range. Remember, open circles, less than, filled in circles, fill it in, less than or equal to. Okay, so looking at our domain, because that's the first one here, domain is our x value, x goes in the middle. My numbers are negative 5 and 6. So negative 5 is at a open circle, so therefore less than. 6 is also at an open circle, so it is less than. Now let's look at our range. Range, remember, we're going from the bottom to the top, like Drake says. So we're going to have y in the middle. The bottom value is the negative 4. The top value is 6. All right, now pay attention to your circles, whether they're open or closed. At negative 4, I see it's matched up with an open circle, so less than. And at the positive 6 here at the top, okay, this is what I'm looking at right here. It's a closed circle, so therefore I'm going to use the less than or equal to symbol. Okay, zeros. Does it intersect our whatchamacallit, x-axis? It looks like it does here and here. And then we're going to have to discuss about that one because that's technically an open circle, which means that point is really not included. Okay, so really then we only have 2 zeros, and that would be at 2, 0. And that's 2, 3, 4, and 5, 0. Now, if we were to do our vertical line test, correct? Okay, you draw a vertical line down this graph. Notice it only touch one time, so therefore, yes, this is a function. All right, I want you guys to attempt this one on your own. Remember, my first recommendation is going to be that you box in this value and write the numbers that go on the outsides. So you need to list the domain, the range, the zeros, and state whether it is a function, yes or no. All right, so now we're going to sketch a graph described. So they're giving us our limitations, and based on that is what we're going to draw. So notice technically we can make our graph a straight line. You can make it a squiggly as long as it stays inside of these parameters. So technically everyone's graph could potentially look a little different. So I'm going to draw a box with these parameters, okay? So we're going 3. So let me just draw points where these values are. And that's not right because that's a y value and that says x. So X, domain, remember, that's X. So X goes from 3 to 7. 3. There's 1, 2, 3, 4, 5, 6, 7. All right, so it's already in that little tiny space. And then the Y is from 1 to 10. So my Y value goes from 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So the Y value has a lot bigger of a range. So X can begin at 3 and 1. So I'm just going to draw where those two meet. And notice they have the less than or equal to sign, hence why I drew a solid circle. And then if I connect where these 2 points would meet, that's where my other point would be. So let me make these points in red so you don't get confused with my other points. Those two. And then I'll just draw a line to connect them because it's got to stay within that parameter. So that's what your graph could potentially look like. All right. Domain here is from 2 to 8. Notice those are just less than symbols, so I know those are open circles. So X is our domain. So 2 to 8, 2, 3, 4, 5, 6, 7, 8. I'm just drawing these points down on the actual x-axis so I can see what I'm working with, what parameters I'll have. And the y value is -1. So we're looking at our y value. -1 to +6. 1, 2, 3, 4, 6. All right. Now, be cautious. We do have one that has an included symbol, so that's going to have to be a different circle at that point. So, where these 2 points meet is that point right there. So that is where we'll have our open circle, okay? And then where my other points meet, here and here, we would have a open circle. And then specifically, they say that 6 is included. So we're going to have to draw it like that. And I can actually move this point. Actually, going to move this point down because you can't have a included and a not included point. Okay, so this tells me this graph is going to be a squiggle graph, essentially. So I'm just going to bring that point down here. Really doesn't matter where I put it as long as it does stay within that line. And deleted my other point. So this graph would look something like this. All right. Well, that is it for today.